Hi everyone, I am Beyza. Now I will present you how to display the physical measurement values of the temperature on a liquid crystal display by using TMP36 sensor. First I will introduce Arduino Uno, then I will describe TMP36 sensor and its characteristics. Then I will continue with curve fitting and show the simulation of it. Then I will introduce the liquid crystal display interfacing with ATmega 328P and I will show the simulation of the design and I will show you the code. Here is Arduino Uno, which is an open source microcontroller board based on the microchip ATmega 328P microcontroller. This is the microcontroller. It has 28 pins here and the functions of 28-pin dual inline package. And here, as you can see this one, here are the same pinout described in relation to the pins on Arduino Uno. This is Arduino Uno. You can see the 5-volt power pin here and ground pins, digital in and out pins here, and analog pins, USB plug, and so on. In this presentation, I will show you microcontroller-based data acquisition and display system for temperature sensor TMP36. The TMP36 is low voltage, precision centigrade temperature sensors. They provide a voltage output that is linearly proportional to the Celsius centigrade temperature. When we look at the TMP36 sensor, it has three legs. First leg is for voltage supply here, and second one is analog pin, and the third one is ground. When we look at its characteristics, it can have 2 centigrade degree measurement error. The TMP36 is specified from minus 40 to plus 125 centigrade degree. Also, as you can see here, it is intended for single supply operation from 2.7 volt to 5.5 volt maximum. For the connections, as you can see already, Arduino Uno has 5 volts voltage source pin. So I connected to temperature sensor here. The low output impedance of the TMP36 and its linear output and precise calibration simplify interfacing to temperature controlled circuitry and analog to digital converters. When we look at its connections to Arduino Uno, first leg, as I said, the red one goes to 5-volt pin. And when we look at the second leg, the orange cable goes to analog 0 pin. Here I used this one. And here I used 1 kilo ohm capacitor and capacitor and 1 kilo ohm resistor for reliability. And the third leg goes to ground here. So firstly, the analog values will be read as digital values by using analog pins. In code, we used analog read function here, and we define temperature sensor as analog 0 pin in the code like that. Also, we define Celsius and value as float because I wanted to see the decimal number, and then the digital values must be converted to physical measurement values. To do that, we use an equation here. How will we find it? By curve fitting. Curve fitting is the process of finding a mathematical function that best describes a set of data points. The goal is to find a curve that passes as closely as possible to all of the data points. With the graph equation, it is possible to change the analog values to the correct temperature values to see on the LCD screen. After getting digital values and their corresponding physical measurement values, by using Excel software, I created a graph. So you can see the equation here and R square value here. As you can see, R square is 1, which means that this describes the best fit between model and the data. So we added this equation to the code here. And this is the simulation of comparison between digital data and physical measurement values. So I'm changing here the temperature values. So you can see that this is the value in the code like that. And according to this equation, we found the Celsius, which is the temperature. So you can see this is the exact physical measurement values. And to show the data on the liquid crystal display, I used the liquid crystal library. So I used in the code like that, include liquid crystal point H. With this library, the display can be controlled using 4 or 8 data lines. I used 4 pins and connected to 5th, 4th, 3rd, and 2nd pins of the Arduino. Here you can see. And I connected them with D4, D5, D6, and D7. And when we look at the register select and enable pins, I connected to 12 and 11th pins of the Arduino. This is the simulation. So when we start the simulation, we can see the physical measurement values of the temperature on the LCD display by using TMP36 sensor. You can see here. And I'm changing the temperature values, and you can see the exact physical measurement values on the LCD display. With decimal numbers because we used float. This is the complete code that I used. Thank you so much for listening.